Okay, now let's look at adding and subtracting unlike fractions using the skills that we've already looked at. The first thing we want to do when we notice that our fractions do not have the same denominator is we want to find the smallest number that all the denominators go into evenly, known as the least common denominator. Then we need to rewrite equivalent fractions with the least common denominator as the new denominator. So these are the two skills that we've just looked at. Then we add or subtract. And remember, we just add or subtract the numerators. Our denominators stay the same. And then at the very end, we look at our final answer and see if we can simplify any further our answer if possible. And by that I mean divide out any common factors between the numerator and the denominator. So let's look at some examples. When we're looking at adding or subtracting fractions, it's really helpful to line them up in this vertical format. It makes it easier to write the equivalent fractions and keep track of it, rather than writing them out horizontally, such as 2/5 plus 4/15 this way. So we notice we don't have the same denominator, and this one's relatively straightforward. We know that 15 is going to be the least common denominator. We can figure that out by inspection because 5 goes into 15 3 times. Now because my denominator doesn't change here, my numerator doesn't. 15 times 1 is 15 and 4 times 1 is 4. So this fraction stays the same. However, here my denominators are different, and the relationship between 15 and 5 is a factor of 3. To get to 15 from 5, we multiply by 3. So I do the same to my numerator. 2 times 3 is 6. So of course I could reduce this down as possible, but I don't want to because now I have my two fractions with the same denominator. Now I can add 6 plus 4 is 10. So my final answer, well I shouldn't say final, but my answer at this point is 10 over 15. Now, step number 4 says to see if this can be simplified further, and it can be. 10 and 15 have a common factor of 5. So I'm going to divide out 5. And that's the final answer. Okay, now let's look at a different problem. So here I have 3 different fractions, and we notice that the denominators are not the same. Now I know that 7 goes into 14, but 4 doesn't go into 14. So I'm just going to use the prime factor method. If I prime factor 2, if I prime factor 4, I get 2 squared. If I prime factor 14, I get 2 times 7, and if I prime factor 7, it's 7. So every factor has to be circled one time and one time only. I have 7 in 2 places. Doesn't matter which one I choose. They both have the same exponent of 1, the invisible 1. So I'm going to circle this one. I can circle this one and cross that one out. Doesn't matter. I have 2 in 2 boxes, but this one has a higher exponent, so that's the one that I choose. So to find the LCD, I take 2 squared times 7, which is 4 times 7, which is 28. So the next thing that I do once I find what the LCD is is I'm going to rewrite an equivalent fraction for each one of my original fractions with a new denominator. And once they all have the same denominator, then I can add or subtract. So the relationship between 28 and 4 is a factor of 7. To get to 28 from 4, I've got to multiply by 7. So I'm going to multiply my numerator by 7 as well. To get to 28 from 14, I've got to multiply by 2. And to get to 28 from 7, I've got to multiply by 4. Now, one thing I've got to be really careful about are these signs. They're going to stay with my fraction. When I write an equivalent fraction, if my original fraction was negative, my final fraction will be negative as well. I don't change the sign, only what the denominator and the numerator are by multiplying by a common factor. Okay, so now I have the same denominators, so my answer is going to have the same denominator. And I find it helpful at this point to write it out like this. Even though I'm going to do my math out vertically, it just helps me visually for some reason to see it written like this. And you'll want to play around with writing out problems in a certain way to see what makes most sense to you. But regardless of the method you choose, you must be organized about it. Don't scatter your work all over. Discipline yourself to write things in an orderly manner so you can follow your work. It'll help your brain work better. So we look at these two values, minus 21, minus 2. And we want to remember that this is the same as minus 21 plus negative 2. So to do this, I take the absolute value of each number. The absolute value of negative 21 is 21. The absolute value of negative 2 is 2. And since they have the same signs, I add. So 21 plus 2 is 23. And the answer has the same sign as the original values. So that makes sense. If I'm $21 in the hole and I write a check for $2, I'm going to be $23 in the hole. So minus 23 plus 24 over 28. Okay, so here's my last step. I'm going to add 24 to this opposite sign, so I subtract. 23 from 24 is 1, and my answer has the same sign as the value with the larger absolute value. 24 has the larger absolute value, and it's positive, so my answer is positive. So 1 over 28 is my final answer, and I have no more reducing to do. So when you add or subtract unlike fractions, these are multi-step problems. So you want to be sure to give yourself enough room on your paper. Take your time. Do not rush through the problem. It'll save you time in the long run if you take your time and make sure you're not making careless errors. We know you want to get through this quickly, but by taking your time, you'll actually be saving time.